So investigation 3.2 is a continuation of what we worked with investigation 3.1, where we were dealing with a nonlinear situation. And so what we have is we have a relationship between the length and the width of a rectangle with a fixed area, and that is not linear. So as the length increases, the width decreases, but not at a constant rate. So that is how we describe a nonlinear pattern. The graph is a curve showing how length and width relate to each other. The relationship between length and width is an example of an important relation called inverse variation. And two non-zero variables, x and y, are related by inverse variation if y is equal to k, or the constant, divided by x, or your x times your y values is equal to k, and k is a constant other than 0. So here are some questions. How does the value of one variable change the value of the other? How is that pattern of change shown in the table of data and a graph? And what equation shows the two variables are related? So here's our scenario. It says inverse variation occurs in many situations. You probably thought about how the length of a trip depends on speed. So Mrs. Cordova lives in Detroit, Michigan, and he often travels to Baltimore, Maryland to visit his grandfather. The trip is about 500 miles away. Here are Mr. Cordova's notes for his trip to Baltimore last year. So, on February 15th, he traveled for 1.5 hours. On May 10th, he traveled 10 hours. July 3rd, 14 hours. November 23rd, 4 hours. And December 23rd, 18 hours. So we know what that is, and these are your x variables. So now we need to figure out y. Well, if we look back into the scenario, it tells us the trip is 500 miles each way. So, if we look at this, we need to figure out his average speed. Well, if it's 500 miles away, we can divide by the time to get the speed. So if I do 500 divided by 1.5, I get 333.3 repeating. Then we move on to the next one. So if I do 500 divided by 10, I get an average speed of 50. 500 divided by 14 is about 35.7 miles per hour. 500 divided by 4 is 125 miles per hour. And 500 divided by 18 is 27.8. So we'll round it. So now we're going to plot this information on a graph and see what it looks like. So, like all graphs, we need to label. So we have travel time on the x, and we have average speed on the y, and again, we need intervals. So along the bottom, I'm going to go by 2's because I can't use just the numbers in the table. then along the y's, I'm going to go up by 50s. And then I'm going to plot my points. So 1.5 is about here. 10 and 50 is there. 14 and 35. 4 and 125. And 18 and 27. So the graph looks like this. Next it says write an equation. So on the front page it gives us two options. Y equals k over x, k being the constant, or xy equals k, the constant. So what did we do for each of these? Well, for each of these we started out with the 500 miles and divided by the time. So the equation is speed is equal to the 500 divided by the time. Or you could write it y is equal to 500 divided by x. Because again, every single time we divided by x and 500. So the question is the relationship between distance and time an inverse variation? Yes, for several reasons. We have a decreasing curve. And the constant is being divided by x.